Okay, so now let me take us through the concept of object-oriented programming. Okay, so we have been looking at object-oriented programming ever since, actually, right? So what is OOP? OOP is simply programming based on objects, right? It's a programming paradigm based on objects. That's simply what OOP is. And it goes on to say objects represent real-world entities and combines data and behaviors. So for example, we have a class here. Okay, let me just use a vehicle class. All right. So we have a class vehicle. Okay, and we also have a class car, which extends vehicle. Right. So we already have a class vehicle which contains these two methods, and we have a class car. Let me change this to car, rather let me leave it as vehicle. All right, we have a class car, sorry. We have a class car which extends vehicle. So what I can do now is I can define some properties such as string car name and let me give another string and say color. All right. And of course I can also have I can also have another vehicle, motorcycle, which extends vehicle. All right, and let me just let this motorcycle just have color, right? And maybe int number of wheels 2, right? A car has 4 wheels. Okay, so object-oriented programming is simply a programming paradigm that is based off of objects, right? So I can create an object for all these classes, right? I can create an object for vehicle, I can create an object for car or motorcycle. All right, let me just call this Let me call this Bentley instead. So this car is a Bentley. Okay. So of course you know that these two classes, right, extends from this vehicle class. Alright. So automatically they inherit these two methods from vehicle. Okay. So I can actually have another car object and call it Mercedes. Okay. So let me change this color to something else, or let me leave it as no, and work with only car objects. Alright, so I can actually access the name of each of these cars, sorry, the color, right, the color of each of these cars. And right now both colors, the colors of both cars are null, right? So the colors of both car objects are null, right? Because of course color has no value here right now. Okay, they are both null, but I can assign colors to them. For instance, I can say the Bentley dot color is red and the Mercedes color is blue. Okay, I can do the same for the motorcycle. I can create an object of the motorcycle, call this my bike. I don't really know. Alright, so I can call this my bike, that's the object of the motorcycle, and I can either access the color which we already have or reassign it. So right now the color is black, but I can decide to reassign and say my bike dot color. Alright, and print the same thing. I can actually also create another object for the motorcycle and say John's bike, and I can say John's bike is, what color should John's bike be? Gray. Alright, so John's bike is gray. Alright, so this is what all these are objects, and using these objects I can still access methods, right? These methods that each of these car objects and this motorcycle object inherits. For instance, Bentley dot start engine. Alright, Mercedes dot stop engine, my bike dot stop engine, and so on and so forth. Alright, so all of this, now we have how many car objects? We have two car objects, right? These two car objects are created from one class. Okay, so we have a car class, right? And inside this car class are defined properties of a car. Okay, so Bentley is a car, Mercedes is a car. They are both objects of this same car class. All right, same way, motorcycle. Sorry, my bike is a motorcycle. John's bike is a motorcycle. All right, and we can have as many objects, right? As many people can have motorcycles, but all their motorcycles are of this same class. I don't know if you get it. All right, so we create objects of this class, different objects of this class. All right, so it says here that objects represent real world entities. Okay, objects represent real world entities, and of course it combines data and behavior. Data can be seen as the properties, each of these properties. All right, and behavior can be seen as the methods of the class, of each class. So that's what it is. Now class is defined here. What is class? A class is a blueprint for creating objects. We have seen this. Okay, and classes define properties and methods. Okay, and what is an object? An object is an instance of a class and it is created from a class. Okay, so we have an example here of an object. Now we have looked at encapsulation, right? When we looked at private variables, private properties, right? And also how to access those private properties using getters and setters. Okay, so encapsulation simply refers to bundling data and methods together, hiding internal details, right? That's the whole concept. That's the whole idea behind private values. All right, hiding internal details from the outside world. That is why that's why they cannot be accessed outside of the file where they are created, right? And of course it provides controlled access to data. So this is the concept of encapsulation. All right, so we have controlled access to data because in order for you to be able to access any data in our class, any private data in our class, right, you will need to have access. You will need to be provided with getters and setters. All right, so if for any reason I don't want anybody to access my private values anywhere, I will simply not have getters or setters. All right, so getters and setters are there so that in case there's anywhere that we need our private values anyway, we can still access them. All right, so that's the whole concept behind encapsulation. And then we also looked at abstraction when we looked at abstract classes and interfaces. Okay, so abstraction simply shows what an object does, how it does it, and it is achieved using abstract classes. That's why we had abstract classes. All right, and methods, methods that we are not defined, just like this. All right, so that's why we had abstract classes and these methods, which we had to implement when this abstract class is extended or implemented. All right, so that is what abstraction does. So what we looked at in under abstract classes, all right, all that is just abstraction. All right. So we also have inheritance. We have looked at inheritance too. Creating a new class from an existing class. All right, and it promotes code reuse. That's why right here I didn't have to define these methods again in these classes, because these classes are inheriting from vehicle. All right, and by default are inheriting the methods of the vehicle class. All right, so it promotes code reuse, right? Yeah, when we create a new class from an existing class. And then we have polymorphism. What is polymorphism? Same method, different behavior, and it is achieved via inheritance or interfaces. Okay, so we have an example here, but I don't deem this example sufficient, so let me do some explanation. When we created methods of these child classes, all right, I instantiated the object. So when we created objects of these child classes, I instantiated the objects with, using instances of their classes. All right, so we have car Bentley initialized to car. So the normally we already know how we declare variables, right? We call the type, we specify the type of the variable first, and then the variable name, and then the value. All right, so the value in this case is the instances of our classes. All right, but this is the type of our object is car. All right, because this is a car object, and the type of our motorcycle, my bike, is motorcycle, because this is a motorcycle object. All right, but then we know that they are subtypes or subclasses of a parent class, which is vehicle, right? And because of that, our objects can have different forms. That is what polymorphism actually is: the ability of an object to have different forms. Okay, so this Bentley now can have the form of vehicle. Why? Because vehicle is a super type of car. You can see car extends vehicle. All right, so car is basically vehicle's child, is a child class of vehicle. All right, so what we have right here is polymorphism. Okay, and if I have another class, let me say class Toyota, that extends car. Now Toyota extends car and car extends vehicle. All right, so the super type of Toyota is vehicle. Exactly. So I can actually create an object of Toyota. The normal way we create objects, right? I'll call this Camry and initialize it to the Toyota object, to the Toyota instance. All right, but I can also use vehicle here. I can specify the type to be vehicle, and this will work. Why? Because I've already explained. Toyota is a subtype, vehicle is a super type of Toyota. Alright, because car is under vehicle, right? And Toyota is under car. I don't know if that explains it. So this is actually polymorphism in practice. Alright, so that is basically what the concept of object-oriented programming is, right? And now, of course, we looked at interface, and it says it is a contract a class must follow. Right, it is a contract a class must follow, and this is best described by abstract classes. All right, so this abstract class, when we remember what we did in abstract classes, right? So whenever we have an abstract class, that is a contract that a subclass, any other class that is either extending or implementing it, must follow. All right, so let's say I have class dog extending animal. All right, this whatever method is in animal must be overridden by dog. So dog must have this method make sound. All right, this method. So, and it also says here that in that any class can act as an interface. Why? Because any class can be extended, any class can also be implemented. All right, so that's that's actually what we see here already. That's what we see here already. Okay, so flyable, we have a flyable class with the function fly, the method fly. All right, so this is a contract that this bird is implementing. Okay, that this bird is following. So because it's implementing fly, it must override, because it is implementing flyable, it must override fly. And of course, we have looked at constructors. All right, the concept of constructors. Constructors are specialized methods to create objects. Now, remember I already told you that whenever we have an instance, all right, whenever we have an instance like this is actually a constructor being called. Right, we're actually calling a constructor whenever we have this, the constructor of the car class. You remember, all right? So, and of course, it is also used to initialize properties, right? In this way, using the this keyword. We have looked at this already. So, benefits of object-oriented programming: modular code, easy maintenance, scalable applications, and real-world modeling. All right, so these are the benefits. Modular code: our code is well arranged, well modularized. All right, and it is easily maintainable, and our applications are scalable. Right, they are scalable because we have objects. All right, we imbibe the concepts, the culture of creating objects instead of calling instances, creating instances all over our code base. We use objects. All right, so because of that, our applications are are efficient, they are scalable, and of course we model real world concepts. All right, real world modeling in our code. Yeah, so this is like a one line summary. Object oriented programming simply talks about classes, objects, and then these four concepts. All right, so whenever you hear of concepts of object oriented programming, just think about these four: encapsulation, abstraction, inheritance, and polymorphism. All right, and of course you cannot have these without classes and objects. Okay, so that will be the end of this lecture. See you in the next part. Thank you.